Alright, good morning guys, it's Miss Lawver, and today I'm going to do a multiplication review of the commutative property. Alright, this is going to become a little game. Today I have you stacked up on SpaghettiO cans. So like I mentioned, we're doing the commutative property, and we have our learning target here for today, which is I can learn the properties of multiplication and division. And you will see other videos from Ms. Seals, Ms. Ziegler, and Ms. Nelson talking about the other properties. And then for our success criteria today here in the green, I am successful when I can use the commutative property to find known facts for 6, 7, 8, and 9. So basically we're just doing multiplication facts that have the bigger numbers in it, 6, 7, 8, and 9. All right, so let's see. For an example, we will do 6 times 8. And if you have difficulty with doing this, this is where you can probably use some of the strategies we showed y'all last week. So I will go ahead and do the rows and columns method. So I'll do 6 rows, 1, 2, 3, 4, 5, 6, with 8 in each row or 8 columns. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8. And you're going to repeat this all the way down till you're done with your picture. And once you finish your picture and you count up all the dots, you will see that you have 48 dots. Okay, so what happens if I took them and I switched the numbers around? What if I had 8 times 6? Would my answer be any different? Well, if I did 8 rows, 1, 2, 3, 4, 5, 6, 7, 8, and I put 6 in every single row. 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. And if I completed my picture like this again all the way down, and when I counted all my numbers up, I would still see that I still had 48 dots. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So if I did this and I added all up, I would still have 48. So what the commutative property shows you is that if you have the same numbers, so I have 6 and 6, and then I have 8 and 8, it doesn't matter which way they go. I could flip-flop them back and forth and that they would still equal the same amount. So I could say that 6 times 8 equals 8 times 6 because they both equal 48. So I'll do one more example for you all on the back side of this. All right, so let's see. If I had, let's do 6 times 7. So again, so we're saying that we can take these two numbers and we can flip-flop them around and they would still equal the same thing. So theoretically, we could say 6 times 7 equals 7 times 6. Well, if I drew my picture out, this time I'll do groups. So the circle dot method. So if I draw 6 big circles and put 7 inside each one, when I add them all up, I know that I'll have 42. Now, if I did the opposite, I'll do a different color here. So if I had the opposite, and if I did 7 big circles, and I put 6 inside each one, and if I counted all of these up, I would still get 42. So again, we would have 6 times 7 equals 7 times 6, which both equal 42. So the commutative property is just a fancy way of saying it's just a fact family. You take these two numbers and you flip-flop them around and you'll get the same exact result. So 6 times 7 equals 42, and then if I switch the numbers around, I would have 7 times 6, which also equals 42. I hope this helps out, guys. Bye.